All right, everybody, welcome to the live. This is your host, Rey Ortega. I am here drinking a wonderful beverage, getting ready to have this conversation with you about artificial intelligence, especially a wonderful, wonderful conversation I just happened to have with a person online. Let's just say they weren't very cordial. Reading about one of my AI posts, they had a lot of things to say. They ended up triggering a very angry version of myself, which I don't get angry much. And I don't usually let social media people respond and get me all flustered and all that kind of stuff. But in this specific case, I had to clap back. I don't know if I'm proud of it or not. I definitely use some choice words. Most people know me that I try not to cuss. My wife does not like me to cuss at all. She gives me the bad Christian face every time I cuss. And but the thing is, before she met me, I had a very foul mouth. I come from the streets, and I said that pretty bad. What I mean is, I actually was born and raised for the first 10 years of my life in an inner city, right across the river from Manhattan in New Jersey. I used to walk 7 blocks to school every day with my brother, my best friend Leandro. We would go to school, walk through a bunch of drug dealers, normal city situation, had to deal with all that stuff at a very young age, had to deal with gang violence, fighting. I got bullied 5th grade year. I used to get picked on by a bunch of gang members. And because I am not capable of taking that kind of punishment, I guess you call it, I used to respond. And I used to respond with my fists. I was a fighter. I always have been, always will be. I've tamed it a lot, obviously, since I became an adult, probably like 18, 19 years old. Met my wife when I was 20, 21, and we've been together ever since. And she was one of the reasons that's got me very calm demeanor, very Christian-like. Let's just put it that way. So when this person kind of not attacked me necessarily, but just attacked my integrity, I felt like I had to respond. And I did. I responded in the words that I knew how. And that happened. And so the funny thing is about that conversation is kind of what triggered why we're here today, why I'm doing this specific live. And this is going to go on to the podcast. If you're listening on the podcast, I believe this is going to be episode 20. I'm going to put this on the podcast. I'm going live because of the fact that this happened. And I think it's beneficial for you guys, not necessarily the fighting part, but for me to provide information that essentially is what this person was having an issue with. They did not understand something about artificial intelligence. And instead of just saying, I don't know this about artificial intelligence, they decided to get weird on me. Okay, so I'd love to tell the story. But before I tell the story, let me kick it off.
The most real and relevant resource on AI and automation. AI Automation Alchemist Podcast. Sponsored by Grata Software.
In this episode, and for you guys that are on the live, you are now the audience of my podcast. For this specific scenario, let's talk about the current state of artificial intelligence in the minds of those that are on the internet, on social media. So I'm talking about a specific post that I did on Threads. If you guys don't know what Threads is, it's essentially a competitor to Twitter or X that was created by Instagram, and it has the same cadence. It's basically textual. It's just Threads. It's just conversation. So in reality, this person was doing exactly what Threads is all about. It's about having a conversation. However, it wasn't a conversation. It was a very specific attack. And what had happened was I posted a thread, and some of you guys might hear this and go, what was the deal? Like, what is the deal? You know, Seinfeld, what is the deal? So my post was why the math behind AI isn't the same as reasoning behind a decision. It says plain language explanation of probabilistic models falls short of true human understanding. That was my post. This response was, how could you possibly know that? We have absolutely no idea how a brain reasons. But I can tell you this, it's all chemistry, thus, it's deterministic, no magic involved. The funny thing is I'm reading that to you right now. It doesn't seem like an argument. It doesn't. It just seems like a observation. My response was just stating, because I was answering that how could you possibly know what the brain is thinking? How can you know that? What's the difference between a brain making a decision and a human mind making a decision? How do you know that difference? His whole thesis here is, how do you even know how the brain works? And let's face it, ladies and gentlemen, we've been handling this type of research for close to 60, 70 years now, if not longer. I believe it was Freud. Is that Freud? Right, Freud was one of the first to really dig into the brain, or not really the brain, but the study of human behavior based on trigger points and all that kind of stuff. But we've been doing studies about the brain. The government's been doing studies about the brain for God knows how long. But when it comes to artificial intelligence, when it comes to the study of artificial intelligence, the human brain, and how we think and how we react and how we reason, all of that was being done back in the 50s and the 60s, led to reports and studies of how do we leverage computer technology to get very similar results from a human brain. However, my response, talking about the years of reading, education, science, all that stuff's out there, you just got to study it. The dude responded back saying, you cannot propose there's a difference when you don't know how the brain works. And at that point, I felt like, am I in the Twilight Zone? Like, I think it's pretty clear. I think we know how brains work at this point. We have scientists that have implanted chips that speak directly to certain parts of your neural cortex that can trigger certain thoughts, certain ideas, certain things. We have studies of how the brain works fundamentally and then how the neurons work. Now, we might not have 100% accuracy on that study, but there is a study. There's many studies. This has been going on forever. And when the idea of neural networks and artificial intelligence came around, those studies is what triggered how we build artificial intelligence today. The level of neurons, that the layers of neurons inside of a neural network, which is called neural for a reason, that is how we layer the amount of quote unquote thoughts. The reason why I say quote unquote, because it's just mathematics. I've said this before. In fact, if you go to my AI Automation Alchemist podcast, I believe it's episode 10, somewhere around there, where I have a very simple way of understanding how a neural network works. And if you go to that, you will get a very simple presentation that Notebook LM, which is an AI tool that I used for it, Notebook LM created a very simple, I just gave it the context of what I wanted it to do, and it gave me a simple way of understanding. I was working at a social media startup as the team lead. I was leading the team of 30 to 35 software engineers. I was one of two leads. I was the back end lead, and there was a front end lead. There was a mobile lead. So there was several of us, but I was one of the ones that had the ear to the CEO, and I would sit with the CEO on major situations when it comes to running the team, how we're going to deliver to production, when do we launch our beta, our alpha, our beta, all that kind of stuff. So I was kind of like the team's advocate. And when I worked at this company, we were doing some really advanced technology that it's very Silicon Valley-ish. It's kind of technology that nobody knows. They don't talk about. Nobody really knew how to do it. We had to hire a whole bunch of people, and then we had to sit in boardrooms and whiteboard. Our walls were white. We had whiteboard walls, so we can write on the wall every time we had an idea or we were having to think through a problem. And I've worked with the top engineers on the face of the planet that are here in Central Florida at the time. And we did an immense amount of work and deep knowledge, deep technical knowledge, understanding. I mean, we were reading books on the technology. We were studying. We were studying like we were studying for a PhD, just so that we could be able to deliver for our employer. And we didn't do it because there was money to be had. We did it because we were very passionate about the work that we were doing. The reason why we were successful, and even in the previous startup I worked at, which was a healthcare company, the reason why we were successful is because we all were very hungry, passionate software engineers and architects. We worked 80 hours a week. There were talks of extra bonuses and stuff like that. But at the end of the day, everyone was making enough money to support their families. So nobody complained about working 80 hours a week, 90 hours a week. And by the way, you'll see that in the Silicon Valley space as well. The OGs of the Silicon Valley space are people that did it for the love of the game. Yes, there was money involved. Let's not lie. Everyone's got to pay a bill, but they did it for the love of the game. The money just happened to be free flowing in that area to where people were able to make a really good living, and you can't fault them for that, right? But the difference between then and now is that in 2006, there was a shortage of software engineers, especially in Central Florida. The municipalities, the government municipalities, the state, federal government, they put a lot of money into increasing the amount of software engineers by providing boot camps, 12-week boot camps, 6-month boot camps, providing new degree programs in software engineering, doing all that kind of stuff. And all of that was under the guise of we need more software engineers because everything's going to plain software. Along those lines, the very, very smart ones realized that most of the software engineers that were coming into the industry were actually people that got into the industry specifically because there was money to be had. Because software engineers at the time were making 120, 200,000, 300,000 fully full benefit compensation. And when I talk about that, I talk about there's money compensation, but there's also benefits beyond that, whether it be health, medical benefits, stock options, all those things. All those things came onto as part of a compensation plan. And so people were jumping like crazy at becoming a software engineer for the compensation plans that were being made available. However, those were the bad software engineers. Those were the ones that came in for the money. When they got the job and they started working, they were the ones that you saw that when you were looking at social media, let's say about during the pandemic, a little bit after the pandemic, remember there was a whole bunch of videos of people saying, "This is my day at Twitter today. This is my day at Facebook today." And it was like half the day was drinking kombuchas and sitting in a sleep pod and all that kind of stuff. It's like they got really 1 to 2 hours of work done a day. Meanwhile, you got the OGs like myself. We're putting in 80 hours, 90 hours a week because we love this shit. This is the stuff that we love to do. This is our passion. This is what we love. And so the guys who were the smart guys, the engineers who were this is what we love engineers, they realized that there was an opportunity to leverage something like an artificial intelligence, or it wasn't artificial intelligence at the time, but it was coding tools that'll help you code faster, more efficient. So you can get more done in a short amount of time. And the idea back then was simply just to make your job more efficient. But as all those engineers became supervisors and bosses, and now they had to think about the business case, not just the engineering case, but the business case. That's where you started to see a lot of focus on using artificial intelligence to essentially replace engineers. Really, it was to replace junior engineers. It was to replace the ones that come in, they do bare minimum, they don't put in as much effort. They're really not there for the cause, they're there for the money, really. And that's kind of what happened there. And by the way, this is all conjecture. This is based on conversations I've had and stuff like that. This is not anything like no one's giving me paperwork that says, Ray, this is what happened. But this is from my experience still working as a software engineer. Even when I started my company in 2014, I was a software engineer still for another year. Like I had the company, but I was doing it at night and I was focusing on the startup that I was working during the day. So there was a pattern. And by the way, artificial intelligence was already there. Artificial intelligence has been around for many, many years. And at that point, we actually had customers and my own job were asking for neural network, predictive analytics, machine learning solution in order to improve company performance, sales, customer acquisition. There were so many different things. So we built what I call true AI. We were building true AI solutions that solve a specific problem that were very deterministic, and that's a key word, deterministic. It wasn't a lot of probability. Obviously, there was in some instances, but most of the solutions were very deterministic. For example, we worked with a company that was a church, global church learning company, I think it was called, and they had a whole training platform for people that want to become pastors at churches. So there was no real hard set rule. If you want to become a pastor at church, you could have just gone to a church and said, I want to learn the ropes and become a pastor. But this organization decided they created a full training program that is certified. And they made partnerships with a lot of churches. So if you're looking for a pastor, you want to get a certified pastor. So when they built their system, they had to build it in a way where they can collect the type of data to understand what is the behaviors of people that are taking their classes, their programs, and then also what are the personalities of the people that are graduating. So all of that is data. All of that is data. Some of it quantifiable, some of it qualitative. And if you don't know what that means, quantifiable or quantitative data is actual numbers, like hard numbers. Qualitative data is labels. So essentially, if someone is a hard worker, you can't really put a statistic on hard worker. So you have to give that term an index or an ID of some sort, which is now an integer, which becomes quantitative. So now if you have a bunch of data that has these numbers that define whether someone's a hard worker or not, you can run real mathematical calculations and figure out if there's a correlation between their hard work and whatever result you're looking for in statistics. That's really what that is. And I'm sorry I'm diving deep into that, but I just want to make sure you understand before I move on with the next statement. And so we're trying to create a very quantitative result set for them on their data. And in order to do that, we had to use regression analysis. And regression analysis has always been around. It's been around forever. If you open up your Excel spreadsheet and use a regular regression analysis, it's usually y equals mx plus b is the function, and it's been around forever in algebra, all that kind of stuff. However, when you're dealing with multitudes of data, multiple levels of data, now you can't just do y equals mx plus b. You have to do a multi. There's a word for it. That's a multi regression, but there's a certain level of power, and each power determines multiple inflection points. I can go on and on about the mathematics of it, but I mean that's neither here nor there. But where I'm getting at is that was 2014, and 2014 around it was actually not 2014. That was 2014. I worked at a startup while Grata Software was up and running. We were up and running, and I worked at that startup for another year, almost another year. It was May of 2015 when my business partner at the time sealed about $100,000 worth of business, and then she flat out said, "Hey Ray, I think it's time to go full time." And it was a no brainer. In fact, the great thing about the startup that I worked at is that the owner, the CEO Oz, who is neither here nor there, whether if he's a good CEO or not, he does a great job raising money. He raised a lot of money. He had leadership skills. He had influential skills because he got investors to invest in the company. And he still owns the company today, and it's still up and running, and it's in 2 different countries. And so Oz was so proud that he threw a party on my last day and actually threw a goodbye, like he stood me up in front of the team, and it wasn't like, this guy's an asshole, he's leaving our company. It was like, look, I wish him well. He's amazing. I hope the best for him. Hopefully we'll work with him in the future. So it was total love, leaving that organization and then going to Grotto Software full time. So this was 2015, May 1st of 2015, and I've been in business ever since. We are now in 2026, so you could do the math. And so it was May 1st of 2015 that I went full time in my business. But the first client that we had was a company that was a nonprofit out of California that was creating emotional quotient training for Fortune 500s. And one of the first jobs that we did was work on a neural network. I think I've mentioned this in a previous podcast, so I won't belabor that point. But just to give you a brief understanding, is essentially being able to build a solid team in a corporate world where you have multiple personalities of people working together and trying to figure out what is the best combination of personalities to work on a specific project to accomplish a specific task. And that kind of data requires neural network and requires machine learning in order to be able to take huge amounts of data and synthesize it into an understanding of clusters. What are the clusters of people that get a high probability of success? And that's kind of where that comes from. And all that to say, we obviously been working with neural networks, machine learning algorithms for many, many years. And now with ChatGPT, which is natural language processing, which has been around since 1966, roughly. I don't know exactly, but 1966. We've been at this, not we, but as a society, we've been at this for a while. And so that's why there's a little bit of a chip on our shoulders. People that have been since the beginning, that's why we all have a chip on our shoulder when we see these people go around and like, oh, we're AI experts. So it's like someone who's playing video games and calling themselves a game developer because they play video games. It's the same concept. You're using ChatGPT, you're using Claude, you're using Grok, using all these tools to do something. That means you're good at using the tools to do something. But that doesn't necessarily mean that you're an expert in artificial intelligence. And to go around and talk to people as if you are an expert in AI, that is disingenuous, I think, in my personal opinion. That's disingenuous. And therefore, I mean, I'm not a fan of calling people out on that kind of stuff. I think I'm a huge believer in Jesus Christ, and I'm a huge believer in faith. And I just believe that, same as karma, like it's going to come around. Like you're gonna get caught, and when you get caught, you're gonna get caught. The amount of money that it takes to build an artificial intelligence solution is very, very. It's huge. It's huge. It's a huge number. 6 months ago, we would quote it would take 6 months and several $1 million just to train a model. Now today, it looks a little bit different because you have open source models out there that are touting that, hey, this is a very cheap model. It does the same, does pretty similar results. However, the problem is that it's a distilled version of the versions that are more expensive. These Chinese models and the models that people are using, like those Chinese models, they actually use ChatGPT and Claude and stuff like that. And what they do is they distill the data that those models create in order to reduce the cost of creating their own models. That's neither here nor there. That is a strategy, and it's working for the Chinese. However, this is the part that gets me about where we are as a society when it comes to artificial intelligence and the chat and the models and all that kind of stuff. The models are getting more expensive. Right now, investors are supplementing the actual cost of artificial intelligence. They're supplementing the cost that we don't have to pay to use the tools. That is why today you can have a $20 a month plan and you can have very good use of artificial intelligence. The problem is, and this is the misconception that we have in the market space, is every time a new product comes to market, let's use hard drives as an example. When hard drives came out, a hard drive cost $300, $400, $1,000, a big device, right? And then over time, the industry starts looking at this product and starts figuring out ways how to make the chips smaller, how to make device smaller, how to mass produce them, how to mass produce the components in order to reduce the cost, the overall cost of the product. And then they were able to get hard drives down to $50, $60, $70, whatever the case may be, because there was an economies of scale. And that's always been a business strategy of price reduction, has always been there's an economies of scale. However, with artificial intelligence, it's different. With artificial intelligence, the more users on it, the more expensive it gets, because there's a mathematical computation here of, as one person using the resources, it costs me X. However, if two people use those resources, it's now X squared. It's not 2X, it's X squared. Because the problem is both those people are not just going to be doing one task. They're going to be loading it with multiple tasks. Now you add another person, X cubed, add another one, X to the fourth, X, and so on. And it just keeps exponentially increasing the amount of processing, memory, all of that. In the past, or in every other technology, that usually that has never been the case. It used to be like a hard drive used to be, okay, one user, 1X, two users, 2X, and so on and so forth. But with artificial intelligence, there's a lot more processing that has to happen for every single request, and depends on the complexity of the consumer of how complex they are going to make those requests. And as you know from now, like when people are using OpenClaw, when people are using all these other harnesses that just do consistent work, that just loop through work. And now you hear loop engineering. This is another terminology that's now being thrown out in the marketplace. And loop engineering is just being able to create a system where it constantly looks over itself and makes sure that it's doing what you said to do. And as it's doing that, it gives itself its own permission to continue doing the work. So it's just looping back. It's almost like an infinite loop. And that just costs more and more tokens and more processing, more and more everything. And that's the problem. The problem is, like, we're not talking about that. We're not talking about that part. And that's why things are going to get more expensive. That's why processing gets more expensive. That's why hard drives get more expensive. Everything gets more expensive. Because you got to build out more and more data centers. You got to build more and more racks of equipment in order to handle all these requests. And right now the industry is, or not the industry, but the consumers, they just don't understand that concept. So the argument is, it's just going to get cheaper from here. We're going to be able to do more with less. All those kind of things. And to be honest with you, like, in the grand scheme of things, normally, yes, that would be the answer. But it's no longer the answer. With artificial intelligence, it's not like that. It doesn't work that way. The only way that would work, in my mind, and this is just me spitballing, is there would have to be some type of a processor that is able to handle more and more tokens per session using the same amount of resources. So not needing to use more processing, not needing to use more memory, more layers of memory, caching, all that kind of stuff. It would have to basically be able to handle more tokens in order to be able to get the same results or better result, but using the same, like, one processor, two processors, three processors. Which there's companies out there, by the way, Cerebras. If you ever heard of Cerebras, that is a company that I've been following for probably 2 years now. Actually, it was an intern that I had hired for my client, who got me caught onto Cerebras, and their specs on their processors show that they can handle, I think it was like 5 or 6 times more tokens per second on their processors. And those processors have internal cooling built in. So in all likelihood, if it is what it is, if it is what they say it is, and other engineering or other CPU companies are building CPUs that are very similar, there's a good chance that we may have the ability to have CPUs that can handle a significant amount more processing with a limited amount of heat. So that means reducing the amount of power costs and be able to produce the same results, if not better. And that would be the answer. The problem with that answer is that that's a 5 to 10 year window. That's how far away we are. And right now, the amount of money that these large language model companies, the amount of money that they're spending versus how much they're making as far as revenue, they can't wait that long because they will literally go bankrupt. They're losing billions of dollars per year, again, because of the fact that the investors are subsidizing the token usage. You and I are not paying the price, the real price of what it takes to buy these tokens. You and I are not spending that money. It's all being funded by the investors. That's why you see these large new rounds of funding at like 300 billion, 500 billion. Like these are huge numbers. And if you divide how much they lose per month, how many billions they lose per month, that gives you essentially the run rate until they run out of money. And if you can figure it out, you'll find out pretty quickly that we're talking 12 months, 15 months, right? We're talking about a year or two that they're going to run out of money. Meanwhile, the window for all this technology, this hardware, power, CPUs, all that stuff is a 5 to 10 year window out. And I don't mean to sound doom and gloom, by the way, because that doesn't necessarily mean the technology is going to go away. So let's be honest. The technology is too big to fail at this point. However, what I think is going to happen, this is my personal opinion, and I'll leave you with this. This is the last thing I'll talk about. I'll leave you with this is the fact that this has happened. This has been a cycle ever since I've been in the industry. Like I said, over 26 years. This has been a constant cycle in technology, and it happened in the 1999 tech bubble that happened, the crash. What happens is that you have these companies that are very heavily cash flowed. So Apple, Google, Microsoft, they have a lot of cash flow. They have a lot of capital. And a lot of these companies, what they do is they may not seem very innovative. They're huge companies, right? So they may not seem innovative in their current state because they're a huge company. But what they usually do very, very well is they sit in the they wait in the wings. They wait for these companies, these emerging tech companies like an Anthropic or OpenAI, to get to the point where they either go public, which they are going IPO. Everybody's trying to go IPO this year. They go public. And then what ends up happening is that the value of the company is no longer there. And the company itself may potentially have to file for bankruptcy because they may not be able to pay their own bills. And what ends up happening is these bigger companies that are very well cash flowed have a lot of capital. Because if you think about it, if you have a lot of capital, you have a lot of assets. If you have a lot of assets, you have leverage, just like Elon Musk did when he bought X or Twitter. He had leverage. So he went and found people that are willing to invest or even loan the money to purchase a company, even if that company seems like it's completely out there and unpurchasable by any normal person. And so what happens is companies like the Microsofts, Apple, Amazon, or even Google are just waiting in the wings for Anthropic and OpenAI to get to the point where they may have to file for a Chapter 11 or Chapter 7 bankruptcy. And they may come in and make a sale and make an offer to buy the company and its technology for pennies on the dollar. Therefore, all the stockholders are going to, basically eat shit because it doesn't matter at that point, right? Because the shareholders are public. They're not, well, a lot of them are going to be institutions, but at that point, it doesn't matter. The institutions don't have enough power when it comes to voting power to say, no, we don't want that. And so what ends up happening is there'll be a hostile takeover by any one of the big 3-4 tech companies, and they'll buy OpenAI or they'll buy Anthropic at pennies on the dollar. And essentially, they'll take over the technology, and now the technology will be well-funded, well-structured, because they have the capital to not only house the servers, the data centers, but they'll also have the capital to enhance the technology. And they're all working on their own processors, memory, all that kind of stuff as well. They're vertically integrating on that just so that they can be able to prepare for that moment where they now have to use their own stuff. In fact, I think today, as I'm speaking, I think Microsoft has already issued a referendum inside of Microsoft to stop using Anthropic and now use the internal large language model that Microsoft has been working on in the background. Again, it's a pattern. I've seen it all these years I've been in the industry, and I'll never get out of this industry. I love tech. And that's the reason why I have Grata Software. That's the reason why I have my company Go Digital Strike. And that's why we support small business owners, entrepreneurs, even medium-sized businesses, but businesses that are looking to grow and scale and expand to become that Fortune 500 one day. And they obviously are trying to find where in their business they can make those moves from a technical perspective. That's what we do. We come in there and we help them make those decisions, and we help guide them through those decisions. And sometimes, most of the time, my team will actually develop the technology in those areas. And And that's essentially why we're here and why we love what we do. And that's the reason why we have this podcast, so that you guys can hear it from the horse's mouth, like what's going on, today in technology and AI. That way you're not just getting your information from the ivory tower, but you're also getting it from the boots on the ground, people in the trenches that are actually working on this technology on a day-to-day basis. But that's basically the episode today and the live for today. I appreciate if you've been listening and you've been on, and I will catch you guys in the next video. Peace.